There are two systems for naming quantities of data, and the confusion between them is genuine rather than something invented for exams. The decimal system uses powers of 10. A kilobyte is 1,000 bytes, a megabyte is a million, a gigabyte is a billion. That matches the metric prefixes used everywhere else in science. Kilo has meant 1,000 for 2 centuries. The binary system uses powers of 2. A kilobyte is 1,024 bytes, because 2 to the 10 is 1,024, and that is the natural unit for a machine that addresses memory in binary. So computers work in powers of 2, and the rest of the world works in powers of 10, and the two very nearly agree, which is precisely why the confusion persisted for so long. To end the ambiguity, the IEC introduced distinct names for the binary units, and these are what the syllabus uses. A kibibyte, kibi, is 2 to the 10, 1,024 bytes. A mebibyte, myb, is 2 to the 20, 1,024 kibibytes. A gigabyte, GB, is 2 to the 30. A tbbyte, TB, is 2 to the 40. Notice the pattern in the names. The bi in each one stands for binary. So kibi is binary kilo, mebi is binary mega. They are awkward words and almost nobody says them aloud, but the exam uses them and expects you to as well. And the smaller units below all of this, a bit is a single binary digit, a nibble is 4 bits, and a byte is 8 bits. Now, the arithmetic that makes this worth understanding rather than memorizing. At the first step, the two systems are almost identical, 1,000 against 1,024, a difference of 2.4%, barely noticeable, but each step multiplies and the small discrepancy compounds. At mega, a megabyte is 1 million bytes, and a mebibyte is 1,048,576. The gap has grown to about 4.9%. At giga, 1 billion against 1 billion, 73,741,824, about 7.4%. And at tera, the gap reaches roughly 10%, which explains something you have almost certainly noticed. You buy a hard drive labeled 1 terabyte. The manufacturer means 1 trillion bytes using the decimal standard. Your operating system reports capacity in binary units and divides by 1,024 3 times over, giving about 931. So it displays 931 gigabytes and you appear to have lost 69 of them. Nothing is missing and nobody is lying. The two are counting the same bytes in different units, but the gap is real. It grows at every step, and it is why the IEC names exist at all. Converting between units is a two-part rule, and it is worth stating in the form that stops you going the wrong way. Going from a smaller unit to a larger one, bytes to kibibytes to mebibytes, you divide by 1,024. Going from larger to smaller, you multiply. The check that never fails. A larger unit must give a smaller number. If you convert 2,048 bytes and get 2 million kilobytes, you multiplied when you should have divided, and the absurdity of the answer tells you so immediately. And each step is one factor of 1,024. So bytes to megabytes is 2 divisions, and bytes to gigabytes is 3. That is exactly the chain we walked in the image and sound lessons. Take a worked example of the kind the exam sets. A file is 5,120 kilobytes. How many megabytes is that? Larger unit, so divide. 5,120 divided by 1,024 is exactly 5 megabytes. And back the other way, 3 megabytes in bytes. Smaller unit, so multiply, twice. 3 times 1,024 is 3,072 kilobytes, and times 1,024 again is 3,145,728 bytes. 2 habits make these reliable. Write the unit next to every number as you go so you can see what you are converting from and to. And sanity check the direction before you start. Am I expecting a bigger number or a smaller one? Those two together prevent almost every error in this topic. 4 things to take into the exam. First, use the IEC names when the question does kilobyte, megabyte, gigabyte, and know that each is 1,024 of the unit below, not 1,000. Second, remember the powers. Kibi is 2 to the 10, maybe 2 to the 20, gibi 2 to the 30, tebi 2 to the 40, going up in tens. Third, divide going up and multiply going down, and check the direction by asking whether the answer should be bigger or smaller. And fourth, know the smallest units precisely. A bit is one binary digit, a nibble is 4 bits, a byte is 8 bits. The nibble is the one people forget, and it appears in questions about hexadecimal, because one hex digit is exactly one nibble, and one habit worth adopting for the whole of topic 1. Every file size question in this syllabus ends with a unit conversion, whether it is text, an image, or sound. The formula always produces bits, and the answer is almost always wanted in kilobytes or megabytes. So the last two steps of every calculation are the same. Divide by 8 to reach bytes, then divide by 1024 for each step up from there. Practice that chain until it is automatic, because it is where the marks are lost far more often than in the formula itself.